Now that we've looked at the core CLR, let's focus on the libraries that provide the features that we as programmers rely on to build our applications. As we said earlier, the core FX is a series of classes and methods written by Microsoft that are usable in our applications for functionality like file system access, network access, working with collections and link and cryptography and the console window and much more. So the core FX, the libraries again in the .NET Core, contain a subset of the classes that are available in the original .NET Framework class library. This was one of the main impetuses for creating the .NET Core in the first place. The .NET Framework class library has grown massive through the years because with each successive version of the .NET Framework class library, they've added new classes and methods and, in fact, entire APIs for things like data access or for the different project types, whether it be the various client-side or Windows applications, web applications, and mobile application APIs that were added to the framework class library. So loading these massive DLL assemblies into memory each time you just need a small portion of what's actually implemented in one of the DLLs severely degrades the performance of the application as a whole. And actually, System.web was the main impetus for starting this whole movement in the first place, as we'll talk about in the ASP.NET MVC Core 1.0 course. So CoreFX is an attempt to pare down the sheer size of those libraries and, most importantly, refactor classes into different assemblies so that, first of all, they can be loaded up into memory independently of each other. So you're only grabbing into memory those parts of the library that you actually need at the moment, not the entire library all in one fell swoop. And then also they can be updated independently of each other. So if you have changes that are out of band with the rest of the framework, that's fine. We'll just distribute new versions of those CoreFX library APIs inside of NuGet, and when you update your NuGet package, you'll grab the latest API that works with network while all the other APIs are left alone, okay? So you can update independently, and then they're running in memory in much smaller packages, so you're not uploading so much into memory every time you run it. Those are the main impetuses. So the .NET Core contains many of the same but fewer APIs as the original .NET Framework's base class library. Furthermore, in some cases, the classes may have been refactored. So assembly names will probably be different. The shape of the classes might be different. In other words, the methods, their method signatures, and the properties themselves, they might be different in a few key cases. And it's expected that the CoreFX, since it's based on the .NET standard, that it will grow to include more of the .NET Framework base class library API over time. We'll see that parity growing in the very next version, 1.1 of the .NET Core. So if the classes that you need today are not present inside of CoreFX, then I would expect in the next year, 2 years max, you'll see that there's definite parity between what you currently have in the original, the full .NET Framework base class library and CoreFX, okay? But today there are some significant differences between the BCL and the CoreFX, and it's actually considered pretty unwise to just take your existing code that targets BCL and just try to apply it straight to the CoreFX and say, oh, I'm going to take this code that I wrote 3 years ago and I'm going to target it to Linux and Mac OS. I'm just going to change out the dependencies and copy the code over. Because there's no parity between those, or there's very little parity between those two today, they said Microsoft's guidance is that you shouldn't even attempt it. Usually this is going to require a complete rewrite of that code. Maybe later on there won't be so much difference, and maybe there will be some tools that'll help to make that process a little bit easier. Now, I would recommend that as you're getting familiar with CoreFX, that you bookmark this web page that you see on screen right now. This is the starting point for all the APIs that are in the .NET Core class library, also known as CoreFX. And if you're brave enough to actually dive into the source code for CoreFX, here you go. It's all implemented. Again, the great thing about open source is you can just jump in here and take a look at what it took to implement a given method or class inside of the library. All right, so I mentioned this .NET Standard library here, and I want to talk about that for just a moment. So actually, I mentioned .NET Standard a couple of times. Is that something different than the .NET Core? Is that something different than the Core library? What's its relationship to these? So CoreFX, as well as all the libraries that were created since the advent of the .NET Framework class library, the original one, they follow a standard, a baseline of features. So think baseline. There will be features that are added on top of it, but when we're talking about the standard, we're talking about the minimum set of APIs, methods, properties that are required in order to meet up with a given version of the .NET Standard library in order to be compliant with that standard. So the standard is called the .NET Standard library, okay? And it's just a standardization process. So the .NET Standard library is a formal specification. It's only a specification. You're not going to be able to download this and use it, okay? It's a specification of the .NET APIs that are intended to be available on all .NET runtimes. So the motivation behind this, or behind the standard library, is establishing a greater uniformity across all of the .NET runtimes, whether it be the original .NET Framework, now the .NET Core, or even Windows Universal Platform, Xamarin, and so on. All right. So think back years ago, if you're familiar with when they took C# and the .NET runtime and they made that into an ECMA standard. So in ECMA 335, which was the standard for C# and the .NET runtime, it was established to enable uniformity for .NET runtime behavior. And so that standard is what allowed the Mono project, which later became Xamarin, to actually build the first cross-platform version of the .NET framework that would run on Linux and the Mac. However, the ECMA 335 only defined .NET runtime behavior, not class library. All right. So what about the class library implementations? Well, there was no standard, which made the task a bit difficult for the Mono team to duplicate. They basically had to reverse engineer the .NET Framework class library, define all the methods, and then figure out, well, how we're going to implement that in order to get basically parity, similar results to what you saw in the .NET Framework library that ran on Windows exclusively. So now the .NET Standard has been introduced as a formal standard in order to fill this gap, so that now we not only have a standard for C#, the language, for the .NET runtime, but now also we have a standard for the library itself, or the different versions of the libraries. So the .NET Standard library enables some key scenarios. First of all, it defines a uniform set of APIs, so library classes and methods, for all .NET platforms to implement. Secondly, it will allow developers to produce portable libraries, so DLLs, assemblies that are usable across all of the .NET runtimes using the same set of APIs. So in other words, if I'm targeting a particular version of the .NET Standard, I know for a fact that this portable library will be usable on this platform and that platform and that platform, but I'm going to be excluding these other platforms. All right. So when you consider how many NuGet packages your application relies on, can those be used with the .NET Core? Well, it depends. It depends on what version of the .NET Standard that portable library that you're grabbing down from NuGet depends on. What does it support? What version of the .NET Standard library does it support? The third key scenario that this supports is that it reduces and hopefully completely eliminates conditional compilation of shared source due to .NET API specifically written for a given version or operating system platform. So again, the hope here is that you don't have your code split off in a bunch of different compilation dependent or environment dependent compilation conditionals. You can just say, hey, I'm writing this one time, I'm targeting this version of the .NET Standard. I know it will run on .NET Framework, Windows Universal Platform, .NET Core, therefore Mac, Linux, so on. Okay, so let's talk about how to determine the compatibility of the .NET Standard? Well, the various .NET runtimes each implement a specific version of the .NET Standard library. Again, remember, the .NET Standard is a baseline. A given library might tack on additional features on top of that, but if you rely on those features, then you are not targeting that specific version of the platform, okay? So each .NET Runtime version will advertise the highest .NET Standard version that it supports. And that basically says, I support, for example, version 1.3. It also means that I would support 1.2, 1.1, and 1.0 as well. So the easiest way to look through this, there's actually this .NET Platform Support URL that you see on screen right now. And it will show you the platform name. So here's the standard. So 1.0 through 1.6. Here's the .NET Framework, the original .NET Framework that we know of. The current version as I record this is 4.6.3. And then here's .NET Core. And you can see it starts off with 1.0. Here's Mono and Xamarin and Universal Windows Platform, Windows Phone even, and Windows Phone Silverlight. So you can see that these will support a minimal set of features, but as we go forward, the .NET Framework 4.6.3 supports 1.6 version of the standard, and which is the same that the .NET Core relies on. So if we're being consistent here, we want to make sure that the features, for example, if we want to create a portable library that will only use the features defined in 1.6 of the .NET Standard. Now, again, we know that the .NET Framework 4.6.3 has a bunch of additional features that are not found in the standard and not found in .NET Core. If we rely on those features that are not defined in this baseline feature set defined here in 1.6, then our portable library will not work with the .NET Core 1.0. All right, so that's the way that you read that. All right, so let's talk about some key takeaways. First of all, the CoreFX is the new .NET Framework base class library. It conforms to a specific version of the .NET Standard library like we see on screen. Still, it's only a subset of all of the classes that have been implemented here in the .NET Framework 4.6.3. And there's an expectation that as we move this number to .NET Standard 1.7, 1.8, or even 2.0, and we look at the new versions of the .NET Core, we'll have more parity between all of the features implemented in the .NET Framework and .NET Core 1.1, 1.2, and so on. So there's some expectation that this will continue to grow until they kind of meet up with each other. So in some cases, CoreFX classes and libraries will be refactored into different assemblies and different namespaces, and their shape, in other words, their properties, the methods, the method signatures might be a little bit different. For this reason, it would be very difficult to simply put an existing code base and point it to the CoreFX. It would probably require a complete rewrite on your part. The .NET Standard, which we're looking at here on screen, is the new portable class library, essentially. If you want to create a class library that will work with both the original .NET Framework as well as .NET Core, then you need to create your class library to make sure that it only implements those features that are defined in the library, in the standard library, 1.6 in this particular case. You need to create it to conform to a specific version of the .NET Standard. And so that pretty much wraps it up. And now let's continue on in the next video. We'll see you there. Thanks.